And hello, this is Algebra 2. We're in Chapter 8, Section 3. This is page 3 of the notes. We're moving right along. This is going to be the longest page, though, without a doubt. We've got this nice long example followed by 2 checkpoints that are much more involved than their tiny boxes would indicate. All right, now we have this example 3 where it says m is greater than n, which means that the numerator has a bigger degree polynomial than the denominator. You look at it, you say, oh yeah, look, the numerator is quadratic, the denominator is linear, so quadratic wins in a cage match. So, first of all, the numerator, start with that numerator business. It factors, right? It's x minus 3 times x plus 1. So, zeros, right? Zeros come from this bad boy being x equals 3. And zeros from this are x equals negative 1. Didn't look good, though. Alright, so the x-intercepts are negative 1, 0, and 3, 0. Boom, x-intercepts. Alright. Now, denominator. The 0 of the denominator is x plus 2, is negative 2. So the vertical asymptote is x equals negative 2. Boom. Vertical asymptote comes from the denominator. All right. The degree of the numerator is quadratic, so it's got 2 as its degree, is more than the degree of the denominator. And the denominator is linear, so its degree is 1. All right, so the graph has no horizontal asymptote. It has the same end behavior as x to the, and you go ahead and you subtract them, so it's x to the 2 minus 1, which is just plain x. Basically, you divide the leading terms and just kind of ignore everything else. Works out really well. Okay, so let's see how this translates into the graph. Boom. We had ourselves let's see, we have zeros at negative 1. They scaled this by 2's, so it's a little annoying, but we'll live. And 3. We have a vertical asymptote at negative 2. Alright, boom. Oh, wait, nope, more vertical asymptote. Sorry. There we go. And then let's see what else we got. Oh, we're just pretty much ready to start making some points. Oh, no. Yes, ready to start making some points. Okay, so take negative 7, plug it in, and they group them up to take some points to the left of negative 2. So the first x value would be negative 7, and the y value is negative 12. 2, 4, 6, 7, 2, 4, 6, 10. I think that point is right there. Boom. Okay. And then you go ahead and you throw in negative 6 for x. That gives you negative 11.3-ish. So negative 6, negative 11.3-ish. Boom. Negative 4 becomes negative 10.5. Of course, your calculator will help you do this a little bit nicer, if at all possible. Boom. And then negative 3, and this is the little interesting thing, negative 3 is negative 12. So we go negative 3 and negative 12. You're like, oh, wait, it's back down there. What happened? And the answer is the graph came cruising off the asymptote, turns around somewhere in there, and starts heading this way-ish. Boom. Now, I said turns around somewhere in there, and you might be idly curious, well, where does it turn around? And the answer is you have to learn calculus. So wait for your future you, and then you'll figure it out. All right, now, you know that negative 1 is a 0. We have this from before. And when you plug in 0, you end up with a negative 1.5. Zero is negative 1.5. And then when you plug in 2, you end up with negative 0.8 ish. So, boom. We still have that other dot from the other x-intercept. You can probably see the pattern of what the graph is doing. It's going zoom. And that's pretty much what's going on. So that's all for example 3. And now we come to the checkpoint. It says graph the function. And you might be like, okay, well, hold on there, Bubba. There's a lot going on here. If you're brave, pause and come back and see what the answer is. And if not, just kind of I'll show it all in a minute, and you'll see what's going on. But I'll give you a few seconds to pause it if you'd like to try it. All right, well, here we go for the very first checkpoint, I guess checkpoint 2. I put all the information there. Let's see, the numerator has the zeros at x equals 0, so that's where the x-intercept is. The denominator has its zeros at negative 4 and 4, so those are your vertical asymptotes. Because the powers are even, because the degrees are even, the horizontal asymptote is at 3, because that's 3 over 1. So I drew those asymptotes, horizontal and vertical. I put in that x-intercept right there at 0, 0. And then I started looking for points. First, some points to the left of the first the first vertical asymptote, and then some points in between the two vertical asymptotes, and then some points to the right of the second vertical asymptote. So just a few points in each clump, drew the curve, boom, 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 arrows on each little end piece. You've got yourself the graph. Now, that's not trivial. I mean, this is some real work here. And if you're feeling up to it, you might want to give number 3 a try as well. It's very similar, although there's one key area in which it's different. I'll pause for a few seconds so you can pause the video if you want to try it yourself. All right, well, this is it. First step you're going to want to do is factor the polynomials if possible. So you see in black right next to the written problem I factored the numerator, x plus 4 times x minus 2, because that gives you the x-intercept numbers really quickly. The vertical asymptote is at 1. There's nothing interesting there. And then there's no horizontal asymptote, and that's because the degree of the numerator is bigger than the degree of the denominator. Make some points. Let's see, your vertical asymptote is at 1. So I chose x equals negative 2 and x equals 0. Gave me a quick look at a couple values. I plotted them up and zoom, zoom, a curve together. And then I plotted some points after 1 to the right of 1. So I did x equals 3 and x equals 5. Got those y values and zoom, zoom together to get some sort of curve to the right of the asymptote. Now, there's one thing I do want to say. In green here, I said there's no horizontal asymptote, and that's very true. However, the end behavior, what you have instead of a horizontal asymptote, is y equals x squared over x. Those are the leading terms from the polynomials. There, I circled them in green there. And so that's just y equals x. And you know what you could do if you're interested in this sort of thing is you could just draw the line y equals x like it's an asymptote, because actually it sort of is. Actually, because what that means is that the graph is eventually going to curve around and be really close to that set of values. Now, it does a little of its own funny dance in the middle of the graph, what we're looking at, but the curve will eventually go to that green slanted dotted line that I made. That's the end behavior. If this last bit doesn't make sense, that's a detail we can definitely sort out in class if necessary. So let the green dotted line go in your head if it's bothering you, but if you're curious, that's what happens. Anyway, that's it for this checkpoint. That's it for this page, and that's it for this section. Thank you for watching.